you press the start.
Probably this is the one.
And then you kind of say, maybe about some icons. Of course, some of you can read in Chinese. Let me explain. This one is the data indicator. So when you press this data, you'll see the data. Now, before I press it, it's developed based on this. You see, based on this, nothing. Based on this appear, nothing at all. If your race being supported with race red light based on it, okay.
The prism.
That one is that's correct. Alright, so now let me turn on the overview. So there's a press there's a catalyst. You hear a sound click, and now let's check again. There's yes, look in my hand.
You can see that's the laser beam. So you emit the laser.
Look at the laser pointer and hurt your eyes. So now we is really you see the part is
and the reflector is you see again the far point your reflector there. So I'm targeting the reflector. It's not easy. You want to target the reflector, it takes some time. I'm still searching how to target. Take a look. Yeah, pretty much now. You see? So this is a reflector, and the reflector reflects the laser beam. So the total station will receive the reflection as well. So it's a bounce back.
You pretty much in the center just tighten this.
Yeah, once you find a target, tighten your screw. Now I'm looking for the laser, whether it's a target or not. You see, it's in the center. Laser is in the center. Refraction. Today we'll teach you some theory about this laser beam. How come you can measure distance based on which theory? And also a receiver as well. Oh, let's say so this is the main one, the modern one, the most used one nowadays in this world. People normally use total station like that one, and very few people use tape or simple electric device. They have to combine different kind. In particular, your device can measure distance and also angle. That's the basic equipment. Nowadays, all the machines are equipped with this one. And if possible, probably when we start, we will have a class lecture. Maybe I try to borrow this one, the total station, for you guys to train this one, because it's not difficult. It's not difficult because all the measurement distance will be recorded in this one. Once it bounce back, you have a distance over here. So it means you don't even know. You don't even need to know the theory too much. But of course, you need. I mean, the machine-wise, the machine will tell you. But how can you make sure the machine is correct? Sometimes it's correct the machine as well. So you have to do some correction. So that's the reason you still need to know some theory. Okay, so that's pretty much we stop here. So you pretty much look over everything in the lab. So everything in the lab. Maybe there's a picture showing you everything in the lab. Maybe this one. I took one picture showing all the lab. So take a look. What do you have in the lab? Maybe to turn your hair around. I think I put a video upside down or something. Okay, so this is the refractor. And this is a bar for the refractor. To put a refractor, the prism on top of it. and all these I think they are just this is your tape. This is your steel tape. It's a steel one. It's a big one. It's a big one. 15 meters. You can see 15 meters. And this is a head. Normally people will have to do the job. And this is nothing. This is just rubbish. Continue. And you have a helmet for safety reason. Also, I think this is sort of like some kind of a rod or something. And then comes to all sorts of machine. And this one is the lever, leveling. So I think it's just have one function. Nowadays they all been combined into total station. So this is a level. You see, auto level. And I don't know the name of this one. It's sort of like put on top of the tripod. You put this on your button. This is a battery. This is a battery. You see, the charger, battery and charger over here. And this is the another one. This is called also the level. Probably another type of level. You see, it's inside. I didn't open it. I didn't open it. And this is also a level. They all look pretty much the same. Even you open it, they're pretty much the same machine. Just different functionality. And this one is a GPS. Unfortunately, I didn't operate the GPS because you need some space. In the lab, you can't operate the GPS, so I didn't operate GPS for you guys. But GPS is important. We'll talk about the theory bit. We have a chance. And then this is a handheld sort of like calculator, handheld calculator. And this one, I think is the same for the machine as well, for machine as well. And this basically is for measuring, basic measuring. And this is the total station, the one I show you. This is the total station. So the machine is all inside. You cannot see the machine, but I show you the machine already. And this is electronic device. They are all these they have individual function, but we prefer the total station. Put everything in one. Prefer the total station. Otherwise, all these are individual one. These are individual. You have a lever and you have electronic device. All these are, and then comes the last bit. The last one. You take a look at the last one. What do we have? That's all. This is a total station. It's the same total station. And this lab is quite I think quite comprehensive as well. You have a lot of things. Pretty much all the surveying what you need is in this lab. So indeed you don't have too many tools. But nowadays you have a total station, maybe 3 in 1. And like I told you, you even have this is a tripod. You see the tripod. Different type of tripod based on the terrain you apply to. Different terrain you different use, and also they differ in the height. Some are higher and some are shorter. So depends on your purpose, and it depends also on your observer's height as well. If you are short guys, you just choose a short one. And these are they are tripod. You see, pretty much they are tripod. And you sort of like put something in between to measure the distance as well. And you also have a ruler as well, sort of like ruler. Okay, so you pretty much have seen all the tools and all the machine in the lab. So basically, it's nothing. It's what you see is already everything inside. So it pretty much is nothing. So what's left is how you operate them, and also for operation bit is it's not that difficult. It's just like I say, you just press something. Press the button, you target, use the laser, target something, and they'll do everything for you. So you don't need any, you don't need a lot of professional. Of course, you're a professional. But what I mean is that you really want to operate the machine, you don't take too much knowledge. You can just get on the machine straight away. So it's easy to operate, and the machine will have produced the readings for you as well. So, but what you want to do is you have to make sure what's appear on the machine is correct, and also you have to do some correction depending on different terrain and situation as well. So let me show you. Probably I have some simple measurement or something. Okay, this is a simple measurement. There is a name for this one, but because they all look similar, so I just call them the stuff. Because stuff maybe is for some particular one, but I always call them stuff because they all pretty much the same, different functionality. So now I want to do the measurement. Probably I want to do the measurement. Maybe I forget what I did at this time. So I put up this one first. I supposed to be done by 2 persons, but at that time I only have one. I sneak in. So you put this one first, and then you start to use the machine. I think I operate that machine. Maybe I'm sure. Let's take a look. I put them up different type of for stuff for your comparison. You see different type of stuff. Okay, maybe there are 4 in the lab. There are 4, so I set up all the one. So they have a different functionality. And in the back, if you turn it around, in the back, you see, I turn it around. Yes, I turn it around. You see in the back, you have a ruler like the number indicate. Maybe it's about meters or about foot. Different number, different meaning. You have to look at the book and take a look and what's the number for. What's the number for? So basically, you have a different type. So when you target this one, you can look at easily. You have white and black and white, so it's easier for you to target this one. Again, you see in the back the numbers. All these numbers, some of them indicates as meters, some of them is a foot, and so different measurement, And this one probably is this one probably is for what's the functionality as well. Most of the time you can see people use this one. So basically you can set up this one for your prison as well. So this one is a multi functional. You can do it for a lot of things. You can set up, put this into the ground and set up your things over here. Probably for a prison is easier. And this is the one I show you guys. It's quite lengthy. Probably it's I think it's 3 or 4 meters long in total. I cannot quite remember. 3 or 4 meters, quite long. In principle, we all call them stuff as stuff. Just the name for the. But indeed, they are individual name. But in general, people call it stuff. Okay, so that's the target. Apart from a prism, so I suppose to put a prism over here as well. So apart of prism probably is the one supposed to put on top of this one. You put a prism over here. So in total, there are 4 type of target, but indeed there are only 2 because these are for the rulers for the target. Look at the label itself. But this ones are for reflection, reflector over here. So in principle, there are only 2 types. One is use your naked eye to look at them. One is use the machine. Use the machine will detect the laser beam automatically to do everything for you. So this one, but nowadays people tend to use this one because you have to set up this one and set up this one. It's too much painful. So people tend to use this one nowadays. But of course, you still have to know how to use them because sometimes you don't have prism in hand or many reasons. Maybe it's too expensive or something. So many reasons you don't equip that one. So and also for short distance, this speed probably is better. For longer distance, probably for the prism probably is a better one. It depends on your purpose. If you like, I can post this one somewhere, and then you can take a look of you can enjoy it or something. Take a look. Okay, now let's go to the this part. Let's go to the theory part. So we try to focus on what? We try to focus on the electromagnetics device. electromagnetic measurement, because EDM nowadays is the most popular one. EDM is the most, so you must know something. For the measurement itself is easy. If you do the EDM itself, like I show you, the laser beam. You just turn on the laser beam and then the refract, it will calculate the distance for you. So on the screen, on the monitor, you will see the reading of the distance. Also, you can measure the angles, so you can also see the angles as well. So it's all done by machine. So your job basically is to make sure what's read in the machine is reasonable and it can be corrected as well. And based on the theory, you're supposed to know how it works. Okay, so now we come to the theory bit. Let's come to the theory bit. Let me show you some of the theory bit. So of course, you have to know something about a little bit about physics, because electromagnetic basically is a wave. So basically, you have to look at the wave first. Let's come to the wave first. This is the deck. This is a wave. Basically, you look at these are all very basic physics. Let's start from here, because now we'll probably spend some time on understanding the property of the prism and the property of the total station, of course, the electromagnetic device bit, in order to do some correction for your later on use. Okay, so this is you can see it's like a wave. You go to the ocean, basically you look at the ocean, Pacific Ocean or somewhere, and then you can see there are different type of waves. They've been put together. So all these waves, you have like the pink one. If it is a light, if you look at the light, our light basically consists of 6 or 7 different kind of wavelengths, different kind of wave as well. So basically, it's a combination of different and this one, if they come together, this is an outer phase. It means they are synchronized. They are not synchronized. There is one with in phase, like this one. This one is synchronized. You can see they are pretty much the concept is be like a parallel. You see, they are synchronized. So in this point, they are all in this point are the same. Or this point, you see, they're the same. So this means is in phase. It means of course later on we'll explain what do we mean phase. But for the moment, you can see in phase basically just means they work in the same speed as the same pace as well, same path. So you walk here, I walk here, so it's the same path, back and forth. So every wave, they are all in phase. And let's continue. It's just a basic one. So look at this one. So since based on this one, you have something called phase difference. Phase difference basically is how far they differ. So phase difference basically is to measure how far they differ. What do we mean how far they differ? If you look at any point, look at, for example, if you look at the point over here, this one, the blue, this one for the blue wave. This one for the blue wave is in this point. You see the wave over here, so in the middle of this one. Okay, now let's take a look at the ray one. The ray one, in compared to this point, is over here. You see, it's over here. Everyone. So it means the ray one a bit lagging behind the blue one. By how much? By this much. Because the blue one is already here. Red one is still here, over here. You see, if you skip this point, you can also look at the other point as well. If you look at this point, the blue one here, in compared to the same height, the red one is over here. So they have this distance are same. This distance are same. We call this distance called phase difference. Later on, we will express this theta. Based on the radiance directly. What do we mean? What's the exactly? It doesn't mean it's a distance. It basically mean is the radiance. Of course, you can define to be the distance, but normally it's defined by the radiance. So okay, let's come. The reason not to define in distance is because you have many different types of the waves. So in some sense, some wave they might have this distance, but indeed they are quite far away. They quite far away. So you can just use this one as the distance. Okay, let's continue. So phase angle. Phase angle is called the phase difference. So you have an angle. So basically, the theta, we show you guys the theta in radian. Basically, it's called the phase angle or phase difference. Phase difference means they are out of phase. Basically, they are out of phase. By how much? You see, they are asynchronized. They are not synchronized at all. You see, they are asynchronized. So by how much? By this much. If you look at this point as well, this point, they have this differ. This is differ from this one. So this so basically phase difference means how far they apart from each other. They are apart from each other. How far? So if your phase difference is higher, means this one is way behind this one. So if you move this red one over here, move on over here, so you'll create a higher phase. Let me see if I can check this one. You have another one. You can, I think you can. I can't remember last time whether I part this one. Let me see. No, it doesn't work. Doesn't. Use this. Okay. Just to let you know, if you suppose you have a third wave over here, and you look at this one, the wave difference, this one between this one will be larger. It means they are out of phase, even far behind this wave. So depends on the phase angle. If the phase angle is very close, means they are pretty much overlap. The closer, the much more overlap they can create. So the in phase is they overlap completely. In this case, the phase angle or phase difference is 0. If the phase difference, it means that there is no difference. It means they two are the. So you can see how far the phase difference basically can interpret as how far they can overlap each other. So if they are too far away, it takes overlap. Okay, listen. What's this? I think this is an important one. It's but it's quite small. Let me see if I can make it larger. No way to make it. I got this one from Wikipedia, I guess. So maybe I can go to Wikipedia, take a look at this one, because it's very small. But this one is very important. Normally, you can, this one basically, the left-hand side basically is in the radian. And when you turn around, when you look at the point, this point, when you turn around, and this one you can read as a vector. So this vector consists of two vectors, x direction, y direction, y. Y is a red one. So you can, from the blue one, you can see the blue lens, the blue one over here. And from the red one, you can see the red one over here. And then the combination is the green one. The green one is the combination of the two waves. So this is a good one. This one, you can see these three waves. Or if this one can, the green wave can be decomposed. One is a red wave, and the other one is a blue wave. So blue wave, you keep checking. You see the blue wave. You see there is in the x-axis there is one keep on moving. This one, you see. This x1 keep on moving. Basically, it stands for amplitude of the blue one. Amplitude of the blue one, the length, the height of the blue one. You see, amplitude of this one. Keep on moving, and we tend to make a moving. And this, we tend to have this one rather, because this one is only showing, but indeed it's keep on moving. You keep on moving. Okay, so and the red one, you keep track of the red one. Red one will down and up. You see, and down. Basically, is a the red one. You pay attention to the red one. When you reach 0 over here, is M. I see. Keep on okay, and then the highest height is over here, and it goes back highest height to 0. and the highest one down to 0 goes back to 0. And so by keeping track of this blue one and this red one, you have the blue wave, and also you have the red wave. And so this in mathematics, basically we call this as the polar coordinates. We also call the polar coordinates. So the polar coordinates, the x-axis control the cosine bit, the cosine value. So this blue one is a cosine wave. You see, yeah, it's very small, but we'll see the bigger one later on. But now you can see the blue one is a cosine wave. So this one corresponds to if you plot it, this one corresponds to the blue one, and the red one is a sine wave. Red one is a sine wave. So basically, the green one is a coordinate consists of blue one and also the red one. It's consists of sine and cosine. Is this one. So you can see the green one. Green one is a little bit different. This green one is the green one is decomposed into two parts: the blue one and also the red one. This is a good picture, a dynamic one. Unfortunately, it's too small. Let me see if I can make a big one, because this is very important. Because this is about radian. You can read it. This is about radian. This is about wave. So wave can be represented by radian. Keep on moving. And the reason for representing wave in this way is because it's easier to understand. You keep on working on just one circle, and you can imitate every kind of wave. It's good. On the other hand, you can treat this one as keep on moving. If something there, but this can probably come, they can represent this one in wave. But normally it's always here first, and then how can I represent this wave in this one? For example, the concept of frequency, the amplitude. This kind of concept, they are easier represented. You see, the amplitude keep on changing. You can change it. X-axis, the amplitude keep on changing. This one, and the blue one is the amplitude keep on changing. You see. Okay. Let me find out the. So basically, what we need to know about physics is about this bit. About the we call the this bit is called the phase difference. This is about physics, because once you have a laser beam target your prism, you have a laser beam, and the laser beam, like I show you already, you will emit the laser, right? The light, the visible light. Maybe it's infrared light. Maybe it's some visible light. Anyway, it looks like a red one. But you can use all kinds of wavelengths as long as you know how to do the calculation. It doesn't matter. But sometimes people tend to choose the visible light, because you can visualize. Some light you can go far without deteriorate, and the quality without deteriorating. Okay. Now what I'm gonna do is I want to show you guys. I'm not sure. I keep a copy of that one, that picture of in the in somewhere in survey here. Maybe it's this one. Maybe not. This is another one. This is based on the one. Okay. We can maybe this too much. Some of them are useful. So you have different kind of wave. Different kind of wave. So what's this one? This is called energy. Energy. We don't need the energy bit. More like a phase wave. I will skip this one, but maybe this over here. And I think I don't have a copy of this one. I don't have a copy. But anyway, you saw the picture already. I just show you that one. Now we'll come to our main story. Since we already have this one, let's come to our main story. What's our main story? I will go back to the original one. Okay. Now I show you another one is about this is another book. In the very beginning of this lecture, I told you guys we pretty much we use two book, use one. And the one we used to use, indeed, it's not really that good. But in comparison, it's still okay, but it's not really good. But they have their individual advantage, this book and that book. But that one is quite comprehensive, big like handbook. But the problem is that they don't show you any proof, anything. They don't explain too much at all. So it means I have to do the derivation always for you guys. So much explain things about disadvantage is like there are some point they skip it. They don't cover at all. But let's take a look at this one. We don't go back to the tab bit. Tab, I assume tab is you have a good knowledge about tab already. Tab is tab. You just use the tab and then do the correction, the 4 or 5 types correction for error correction. I think that's that kind of knowledge probably is good enough. At least we need extra stuff a little bit later on things. So we come direct to the second kind of measurement. Use the electromagnetic measurement. So first of all, this is EDM. EDM on site today is a total station. So total station, total just means put everything together. You can measure the angle and you can measure the distance. Many kind of function, function can be performed. So this is called total station. Total station. And of course, you can separate them. Separate you have angle measurement, and also you have something called theodolite. Theodolite measure use the electronic one to measure the. I look at them. I try because in the lab I try to see what's the difference between this one and these three. Indeed, there is no difference. They just put this one together into total station. So nothing new. Just put this one, put it into this machine. And for the GPS one, they even put this one total station with GPS. So it's 4-in-1. This is the 3-in-1. It's apart from angle distance. I think there is another one. I can't remember what do we have for another one. Basically, it's angle and distance, but there is another one. Anyway, I remember it's a 3-in-1. And together with the GPS, it will be 4-in-1. And but that one is very expensive. So normally what you can get hold of is total station. Okay, so total station basically you can do the angle measurement, also the distance measurement. That's good enough for basically for all the measurement. And this you are talking about GPS 3D things. Otherwise, it's good enough. Okay, they can also have an algorithm stored into the total station because the total station basically is like a microcomputer. Itself is a microcomputer, a chip. They can run I think it's used. Of course, it's not using Android. I can't remember. Maybe it's using some sort of like Windows system, but not really Windows. It's sort of Windows system. I checked it before, sort of Windows, but not Windows system. Anyway, or maybe simplified Windows system. Okay, so they have an algorithm inside. So if you can write program, and if they allow you to do the programming things, even better. But I doubt it because normally surveyor engineer thing, they probably don't write programming, so they probably don't have this kind of device. But anyway, if you can device your own machine, if you know some programming. Okay, let's continue. And also they follow this kind of machine. They also have another functionality. Another functionality is they can automatic repeat measurement. This is good. This is good. Why? Because normally it's done by a human. Like if you do once, twice, many times, maybe 10 times, recall them 10 times, and then you get the mean of the something. But for the machine, I say everything, and then they can do this just within second, a couple seconds. They can do it between 1.5 to 3 seconds. I can do it many times. So this is good. Very stable. But okay, let's continue. It's a total station. The one I went to the lab, I show you in the video, is this one. It's called total station. They all pretty much look the same. No matter which brand, which company with total station. They pretty much you have some the telescope over here, and you have a screen monitor over here, and you have a laser behind, laser beam behind. I show you the laser, so they emit the laser, and you can, in order to measure the angle, the vertical angle, you use this one. You can turn this one upside down. This is a vertical angle, and also you can turn this one left and right. It will become vertical angle. But once you turn it and you find out the object you tight this screw, then this one will be fixed. If you find out the object of your horizontal object, and then you tight this screw, and it will be fixed. So the machine itself is very simple, right? Nothing special. Just this. This is the whole machine. You have something the laser equipped in front, and then this one the telescope and the monitor. Nothing. This very basic one. Basically very basic one, but it's powerful. It's powerful. You don't save a lot of human activity. So, but you have to send one person. In principle, if you only have one person, you can just go there and then set up the stuff, and then try to move this one, just like I did in the lab. Move this one, try to find out target, but it will take too much time because you don't have anyone to look at the laser straight away and show you by hands or the hand gesture or something. Okay, and you also have a small. I think it's like you can touch it as a touch screen. I can touch it and get some info. That's it. Okay, so all these are the functionality of the total station. But in principle, I just want to tell you, you can measure the angle, you can measure the distance, and also the arrow. The arrow is very small. You see, 8 kilometers to millimeters. Millimeters mistake. 1 millimeter mistake. 1 millimeter is 10 up to -6 meters. So 0.2 is -10 -7 meters. So it's very, very small. You see, it's 10 kilometers is quite long. 8 kilometers is quite long. You only have a very, very small mistake. So this kind of machine is very useful. But it says one name of machine, but they're pretty much the same. It doesn't matter which machine. The functionality pretty much the same. So 1 kilometers only have this one. What's this? 0.1 I think probably is a repetition or something. It looks like these two numbers are the same. I think that is so. Maybe there are two over here. All right. But anyway, we can see it's quite accurate. It's quite accurate. Okay, let's continue. So now we try to classify different like electromagnetics device. What kind of electro device? Based on the wave you use. You can use infrared. You see, IR, infrared radiation. You can use this one. And the one I operate probably is I'm not sure it's infrared, but it is a visible red light. That's all I can say. I'm not sure. I'm sure it's indeed. Yeah, if you keep on reading the book, you keep on reading this one. Later on, you find out he claimed there is no pure. You can't use a pure infrared radiation. You have to combine with other high frequency over here. See, the radiation. It means infrared. You can't propagate the infrared easily. Meaning in the long distance, infrared radiation is not very concentrated, so it's not useful. But to overcome this shortage, there's one you can use high level, high frequency wave. So this wave together with a carrier wave, and you can modulate them, put these two waves together, and maybe you can make it longer and to propagate better. Otherwise, you can't measure long distance. That's in principle. Okay. So also, you can, apart from the infrared radiation, you also can have visible light. And the machine I operate probably is a visible light. I'm not sure it's infrared plus with this one or visible light. I didn't take a look at the book because I'm so excited when I see the laser beam. I say, oh, this is cool. But once you stay with a laser beam for a couple hours, you feel bored because I don't know because you already know the things. So okay. Now let's take a look machine first, and then we'll come back to in the second section. What time is it now? In the second section, I'll come back for the but now we take break because it already certain section. So we'll come back. We'll come to the machine. We'll go to the machine first, and then we'll come back the theory bit. We have a theory to explain all the thing, how the machine operates, and also the characteristic of the prism. They are in principle they are also very important because you cannot just say I can operate, but I have no idea how it operates. Then it will cause problem at some point because you can't explain at all. So let me come to the machine. I want to show you we want to recognize the machine first before we click on all the theory bit. I remember there is a machine in this one. And then we have a machine of the EDM, the structure of the EDM. Understand the structure first, then we come to the theory bit second. Okay, let's take a short break for 5 minutes. Okay, come back. Let's say back. Now is 15. Let's say 21. Okay.